Welcome to my YouTube channel, a Brainery of Civil.
Today I am going to solve the third assignment of Strength of Materials. Let's start. The first question is, which of the following condition represents statically determinacy in a loaded system? He has given four options. Which condition will represent the determinacy regarding static? For example, if you take simply supported beam, the number of reactions here are 2 and the applied load is somewhere like this, and the number of reactions here it is R is equal to 1, and the number of equilibrium equations S is equal to 3, they are sigma fx is equal to 0, sigma fy is equal to 0, sigma mz is equal to 0. That is algebraic summation of forces along x direction and y direction are zeros, and the summation of moments about any support is 0. By using these three equilibrium equations, we can able to calculate three unknown reactions at support A and at support B. That is, when number of unknown forces is equal to the number of equilibrium equations, it will represent a determinate structure. Okay. So for question number 1, answer is A. Next question. If a composite bar of steel and copper fixed at both ends, so I am making a diagram. This is copper and steel. Both ends A and B are fixed and heated. For example, initial temperature is T1 has been heated to T2 degree centigrade. He has given some information. Alpha Cu is equal to alpha steel, that is alpha is equal to coefficient of thermal expansion. So alpha Cu is for copper and alpha Cu is greater than alpha steel. So this information he has given. Then the copper bar is under. So if we have been increased the sample temperature from T1 degree centigrade to T2 degree centigrade, whether the copper bar is subjected to compression or tension or both, so that we have to decide. As he has given the information here, alpha Cu is equal to alpha steel, this copper bar will be extended more when increase in temperature. Okay, so whenever there is an increase in length by the ends are fixed, okay, that is the copper bar is subjected to compression from the ends. Clear? Copper is always under compression because of its coefficient of thermal expansion is more compared to all other elements. Okay, so for this the question answer is A. Clear? Next question. In a riveted connection for plates, the shear stress in a rivet in double shear and will be half to that of single shear for the same load. So whether the statement is correct or wrong. Okay, so first I will draw the diagram corresponding to double shear and single shear. So there are two plates connected by two cover plates. There are two plates connected by one cover plate only at top as well as, or it may be at the bottom. That is, there is one plane here which is being sheared. So here this is a double shear. Two shear planes. it is single shear. It is single shear plane. Okay, so this tau shear, I am taking tau 1. In single shear, tau 1 will be half. Okay, in double shear, the shear is twice compared to single shear. So for this question, the answer is false, because he has given double shear will be half compared to single shear. That statement is wrong one. Clear? Next question. Which of the following material is more elastic than others? So out of all the materials, steel is the more elastic material. That is, elastic means if the object is elastic, the body regains its original dimensions, original shape or dimensions. When the pressure or load is removed over that body. Okay, so that is, steel is the material. Whenever we remove the load over this steel material, it will regain its original dimensions. Okay, out of all the given options. So that is why steel is more elastic than other materials he has given. It may be a glass, it may be a rubber, it may be wood. Okay, for question number 4, answer is D. Clear? Next question. A brass specimen of diameter 15 mm subjected to a tensile pull using a gauge length L is equal to 50 mm. When tensile load reaches to a value P is equal to 50 kilonewton, the distance between the gauge marks increased by, that is, elongation, is equal to 0.1 mm. What is the modulus of elasticity of the given material he has given? We have some basic formula, delta L is equal to PL by AE. That is, when a bar is subjected to certain tensile load, because of this load, the elongation can be calculated by using formula delta L is equal to PL by AE. In this, we need to calculate E, that is PL by A delta L. So what is P? It is 50 kilonewton. I will write this in newtons. Into L is equal to length of the gauge length 50 mm divided by area A is equal to pi by 4 15 divided by 1000 whole square into delta L is 0.1. I will substitute that 0.1 in meters. Here also 50 mm. If I divide this value by 1000, I will get in meters. So here you will get 1.417 10 power 11 Newton per meter square. If you will get converted, you will get 141.47 GPa. The answer for this question is answer C. Clear? So it's a basic formula, direct. Next question. An artificial rubber pad of thickness. So he has given the thickness is equal to 50 mm. Bonded with the two steel plates as shown in figure, the pad has dimensions A is equal to 100 mm, B is equal to 100 mm. So that is, it is a square plate. When top of plate is subjected to shear force V is equal to 10 kilonewton, the rubber pad displaces by 1 mm relative to the bottom of the plate. That is, this top displaced by this point displaced by 1 mm. So that is 1 mm. What is the thickness of this plate? It is 50 mm. The shear modulus of elasticity of the artificial rubber is, we know shear modulus G is equal to shear stress divided by shear strain. First of all, we will calculate this is tau and this is gamma. First, we will calculate tau. Tau is equal to shear stress. Shear stress is nothing but it is shear force over which the area is acting. The force over the area is acting. So that is shear force divided by area. Shear force is equal to 10 kilonewton. I will write it as in newtons. And area is equal to 100 by 100. 100 by 100. You will get it is 1 Newton per mm square. And shear strain gamma is equal to, this is gamma. Opposite side divided by adjacent side. So 1 divided by 50. Okay. So we know value tau and gamma, then G is equal to tau divided by gamma. Tau is equal to 1, gamma is equal to 1 by 50. So you will get it is 50 Newton per mm square. So you already know Newton per mm square is equal to MPa, 50 MPa. Clear? So the answer for the given question is answer D. You can see next question. The temperature of 2 meter long copper rod is raised from 20 degrees centigrade to 75 degrees centigrade and the length will be L is equal to 2 meters. Determine the stress in the rod if it is fixed at both ends. For example, I am taking this is rod has been fixed at left as well as right, and he has given modulus of elasticity 10 power 5 MPa and coefficient of thermal expansion 18 into 10 power minus 6 per degree centigrade. So the stress developed, stress sigma is equal to E alpha T. So that will be E is equal to 10 power 5, alpha is equal to 18 into 10 power minus 6. Here T is equal to difference of temperature. So that is 75 minus 20. So that will be 99 MPa you will get. So the answer is A for question number 7. Next, in this figure shown below, a cable BD of diameter 20 mm, right, supports a steel girder AC subjected to a load 100 kN at end C. The tensile stress in the cable. So now I just cut here. So there is one reaction like this, another reaction like this. I will draw free body diagram. So this is a roller support. This is point A, and this is inclined cable. And the angle here I will measure here. Let it be theta. Tan theta is equal to opposite side is 9 divided by adjacent side is 12. So theta is equal to tan inverse 9 divided by 12. So you will get theta is equal to 36.86 degrees. So here theta. Here tension T, in which cable it is BD cable. I will write it is BD. So if I resolve this into upward direction, TBD sine 36.86 degrees. Here theta is equal to 36.86 degrees. Okay. Now, as end A is a roller support, I will take moment about end A. So, sigma MA is equal to, and there is a load 100 kilonewton. So, this 100 kilonewton will produce clockwise, this will produce anti-clockwise. So, clockwise 100 into the perpendicular distance here it is 12 and 4. 12 plus 4 minus TBD sine 36.86 degrees into 12 is equal to 0. So the only unknown is TBD. TBD you will get it is 222.22 MPa. Clear? So answer is A for question number 8. Now, next question. Figure shows forces acting in a stepped cantilever bar fixed at the right end. If the bar is subjected to 2000 kN load on left end as shown in figure, total deformation of the bar is E1, E2, E3 has given it is 200 GPa. So now, we already discussed that delta L is equal to PL by AE. If there is only one member, then delta L will become only 1 PL by AE. Here there are 3 members having different lengths and different cross-sectional areas. So, delta L, total deformation of bar, delta L is equal to delta L1 plus delta L2 plus delta L3. So, the deformation will be delta L1 here, delta L2 here, delta L3 here, and this will be PL1 divided by A1E plus PL2 divided by A2E plus PL3 divided by A3E. So, in this expression, the load P and modulus of elasticity is same for all the members, L1 by A1 plus L2 by A2 plus L3 by A3. Clear? So, P is 20,000, sorry, it is only 2000 kilonewton. I will substitute in newtons, and E is 200 into 10 power 3. I will substitute in MPa, not in GPa. So, you can convert easily. 100 by 10 plus 160 by 20 plus 75 divided by 15. So, if you will calculate it, this will be 0.23 mm. Okay. So, the answer will be C for question number 9. Clear? Now, some lengthy question he has given. So, this type of questions they will ask in the GATE exam. Okay. A steel rod of 30 mm diameter is enclosed centrally within a copper tube of external and internal diameter 50 and 40 mm respectively, as shown in the figure. The temperature of the composite bar is raised by 100 degrees centigrade if the length of the steel rod and the copper tube is 150 mm, both are having same lengths. Stress generated in steel rod and the copper tube are. So, by increasing a temperature, obviously there is a development of stress. By increasing here 100 degrees centigrade temperature, how much stress will be generated in steel and copper bars? Okay, and he has given modulus of elasticity of steel, modulus of elasticity of copper, and thermal expansion, that is coefficient of thermal expansion of copper and the coefficient of thermal expansion of steel. Clear? So, now, this is some lengthy question. We just put your brain here for maybe 2 to 3 minutes. And he has given length of copper and length of steel is equal to 150 mm. So that is given in the data. And he has given area of steel bar, that is diameter of the steel bar he has given as 30 mm. We can calculate area of steel is equal to pi by 4 30 square. That will be 706.858 mm square. And area of copper is equal to, as it is a hollow section having external diameter is 50 mm and internal diameter is 40 mm. So you will get it is pi by 4, 50 square minus 40 square, that will be 706.855 mm square. And we know alpha C greater than alpha S from the given information. You will get, I already explained, copper will be under compression, that is copper will expand more. We need to compress. So as same, copper will expand more than steel. Okay. Since two sections are connected one in other together, so cannot expand freely. Okay, so copper will be under compression. So when copper is under compression, steel is under tension. Okay, so you can write this theory because it is a very important problem. So now I will equate compressive force in the copper is equal to tensile force in the steel. Now compressive force is equal to compression stress into area is equal to tensile stress in steel into area of steel. So as area is same, sigma C is equal to sigma S. So from this expression, both copper and steel will have same amount of stresses. That is, copper is under compression and steel is under tension. Now the deflection in copper is equal to deflection in steel. That is, the expansion in copper, because it is having more coefficient of thermal expansion, and deformation, that is compression in steel, both are same. So now for this I'll write delta C is equal to delta S. Alpha C into T into L minus sigma C by EC into L. This is deflection in copper. Alpha S into T into L divided by sigma S into ES into L. So in this expression L you will get cancelled. So substitute the values. Alpha C is 18 into 10 power minus 6 into T is 100 degrees centigrade minus sigma C by 10 power 5 plus that is equal to 12 into 10 power minus 6 into 100 plus sigma S divided by 2 into 10 power 5. So in this, sigma C and sigma S are unknowns, and in this expression here, sigma C and sigma S both are same. If we will solve, you will get sigma C is equal to sigma S is equal to 40 MPa. Okay, so in this problem, we have used two conditions. One is stress, that is force on copper is same as force in steel. This is the first condition. And deformation in copper is equal to deformation in steel. This deformation in copper will be extension and the deformation in steel will be compression. Clear? So the answer will be C for question number 10. And coming to the most important question, very logic question. It is a problem of type in engineering mechanics. Generally, you will get one question for 2 marks. Okay, so you can see. A pin jointed tongue holds a block weighing 75 kilonewtons as shown in figure. The coefficient of friction at the gripping surface is 0.1. Assuming that the force is applied along XX and the block is gripped along YY, then the force F required to hold. We need to apply certain compressive force from the two sides to hold that block is under grip. Okay, so how much force we need to apply? Obviously, frictional force required is equal to coefficient of friction into downward force, and force required to produce 75 kilonewton frictional force. Because the weight weighing is 75 kilonewton, the same amount of frictional force we need to develop. Frictional force at section here, YY section, Fyy is equal to 75 divided by coefficient of friction, that is 750. So 750 we need to develop at YY section. So there are two grips on left as well as on the right. So at each grip we need to develop 750 divided by 2. So that is at each grip 750 by 2, that is equal to 375 kilonewton force has to be developed. Okay, now I will take moment about this pin. So sigma m pin is equal to 0. So F into 75 is equal to Fyy into 25. What is this 75? 75 is this much. So this is F into perpendicular distance is 75. This is Fyy into 25. Okay, this is the equation. This into this, this into this, this into this, this into this. So you will get here Fyy we already know it is 375 and F will be 125 kilonewton. Clear? Very logic question. So the answer will be option A for 11th question. Okay, there is one more problem. So this is something like you need to go, first of all you need to go with options. So after a 25 mm long aluminium pipe is placed adjacent to steel pipe 25.02 m long at 20 degrees centigrade. At what temperature will the aluminium pipe is 15 mm more than steel pipe? Alpha steel and alpha aluminium he has given. Okay, first of all I will check at 163.66 degrees centigrade. So here it is, I will take aluminium, here it is steel. So what is the length of aluminium? It is 25 meters means 25,000 mm. Here length will be 25.02 meters means 25020 mm. Okay, so at option A that is 163.66 mm, I will calculate expansion, that is delta L is equal to L alpha delta T. So what is this? L will be 25,000, alpha will be, for aluminium it is 23 into 10 power minus 6. After how much temperature? The present temperature is 20 degrees centigrade. After how much temperature is the remaining difference in temperature is, we are checking at 163.66 minus 20 degrees centigrade. So this will become, expansion will be 82.6045 mm. Okay, and here the expansion will be 43.132 mm. After expansion, the length will become 25082. Here length will become 25063. So now I will calculate this L1 and L2. L1 minus L2 will be 19 mm. What he asked, 15 mm more. So it is 19 mm. So this is wrong. And now at the second temperature 147.38 degrees centigrade, I will calculate delta L as 73.24 mm. After calculating this delta L, I will get L is equal to 25073 mm. And here for steel, delta L as 25058 and L will be, delta L is equal to 38244 mm and 25058.24. So this is L1 dash and L2 dash. The difference from L1 dash to L2 dash will be 15 mm. Okay. So now aluminium pipe is 15 mm more than steel pipe. At which temperature? At 147.38 degrees centigrade. Okay. This is also one of the time taking problem. Okay. You need to check from the options. So answer is B for question number 12. Okay, so these are all the solutions for assignment 3 of strength of materials. In the last assignments 1 and 2, maybe 2 to 3 questions gone wrong because I was very busy during solving the problems. Okay, and if you have any doubt, post your comments. Thank you.